going to do is find the most stable version of trans 1,4-dibromyl cyclohexane. So just looking at the name, we know that we're going to have a cyclohexane with substituents that are bromide at 1 and at 4. It doesn't matter which is 1 and which is 4. 1, 2, 3, 4. So that's 1, 4, dibromo, because there's 2 bromides, cyclohexane. Since they're trans, they're on opposite sides of each other. Therefore, one of them is facing towards me, and the other is away from me. Because trans means opposite, so they're heading opposite directions. When I come over here, and I'm looking for the most stable, we know from chemistry that the most stable version of a cyclohexane is not in a ring form, but actually in a chair conformation. So we'll go ahead and draw that. In the chair. And then we have to determine where we're going to put the bromides. Now, the best way to look at this, from my opinion, my chemistry professor taught me this, is pretend that you're looking down on it with your eyeball. So this is my eyeball, and if I'm looking down at this, taking this structure being the same as this, one of these bromide is going to be facing me, and the other one's going to be away from me. And it's going to be at 1 and at 4. So 1 will be away from me, and 1 will be pointing towards me. Now, as you can see, both of these are 1,4-dibromo cyclohexane, and they're facing opposite directions, so this is in fact trans 1,4-dibromo cyclohexane. However, the most stable version of this is neither in the ring form or this chair conformation where they're both axial. Where it's trans 1,4, that means that both substituents will either be axial or equatorial. Here we have both of these are in axial positions. The rules of the chair conformation state the substituents in equatorial are more stable than substituents in axial positions. So therefore, if we have a choice, equatorial is more stable. So we're going to prefer both to be in equatorial. Therefore, though this is an accurate representation of trans 1,4-dibromo cyclohexane, the most stable version would actually be still the chair conformation, but where both bromides are in equatorial positions. Therefore, this is still correct, because if I once again look at it from this position with my eyeball, there is a bromide coming towards me, and there's a bromide going away from me. This would be the most stable version of trans 1,4-dibromocyclohexane. So to review, since it is trans 1,4, both substituents will be axial or equatorial in order to get them facing away. One facing me, one facing away from me. Equatorial is always more stable in terms of substituents than axial. So since we have the chance that they're going to be both axial or both equatorial, we should always go with both equatorial, as that will be most stable. So these are all the same compound, essentially. This is the most stable configuration of the compound. Thank you.